Lots of things cause objects to accelerate. Think of gravity accelerating things downwards. Think of thrust accelerating vehicles. Think of the tension in a bow accelerating an arrow. What all these things have in common, though, is they are all forces. It is forces that cause acceleration. To be more precise, it is resultant forces that cause objects to accelerate. Newton's second law tells us that the acceleration of an object is proportional to the resultant force acting on it and inversely proportional to the mass of the object. That's a bit of a mouthful, and we could write it down in equation form to make it look a bit clearer. So acceleration is resultant force divided by mass. On your equation sheet you may see that rearranged, so you get resultant force equals mass times acceleration. With the correct symbols it looks like this: F equals ma. We'll look at what resultant force is and look at balancing forces in my next video, so subscribe so you don't miss that or any of my other videos. Inertia is an object's reluctance to change its state of motion. By that we mean how hard it is to change its velocity or to get it moving in the first place. For example, this brick here has a lot more inertia than this calculator here. What we can easily measure is an object's inertial mass. That's normally what we're talking about when we're talking about its mass. The more mass something has, the more inertia it has. The harder it is to get going, or to change its direction, or to change its speed. Let's look at an example. What resultant force is needed to accelerate a 12,000 kilogram bus by 1.5 meters per second squared? Now 12,000 kilograms, that's 12 tons. That's a lot of inertia. We're going to use the formula resultant force equals mass times acceleration. So F equals ma, which equals 12,000 times 1.5, which equals 18,000 newtons. The unit for force then is the newton. It's important also to consider that force is a vector. The sign is important. It can be negative as well as positive. For example, what's the force required to slow down a 1500 kilogram car by 8 meters per second squared? That's quite heavy braking. The car is clearly decelerating. Deceleration is a negative acceleration, so we could write down this acceleration as minus 8 meters per second squared. Before I talk you through this example, can I ask you to take a note of my website, videoplatoacademy.com. There'll be a link in the description. On there you'll find lots of free resources, including questions and answers to go with this video and other videos. If you could also like and subscribe and even comment, I love to read your comments. That would be really appreciated, and it would help me keep producing free resources. I also offer one-to-one lessons as well as small group lessons, and I do my best to keep those as affordable as possible. Back to the question. We're going to use the formula F equals ma. So our resultant force equals the mass, which is 1500, times the acceleration, which is minus 8. Putting that in the calculator, we get minus 12,000 newtons. That minus tells us that force is a retarding force. It's a force that's causing the object to slow down rather than make it go faster. So you may find it appropriate to check your sign when you use acceleration and force, because they're both vectors. Why not watch this? Go on, watch this. Go on. It'll do you good.